Last video you learned hash tables give you O1 lookups, but a function turns your key into a number isn't really an explanation, it's a black box. Today we're opening that box and showing you exactly what's happening mathematically step by step. Understanding hashing at this level isn't just trivia, it's what lets you actually reason about when hash tables will be fast, when they'll slow down, and why certain data types make good or bad keys. Let's get specific. Every hash function's first job is converting your key into a single number, no matter what type of key it is. A string, a number, even a whole object gets processed character by character, or byte by byte through a formula, producing one specific numeric output. Same input, same output, every single time. That raw number is usually huge, way bigger than your hash table has slots for. So the hash function takes that number and compresses it down using something like the modulo operation, essentially divide and take the remainder to force it into a valid slot index within your table's actual size. This is the property that makes lookups work at all. Since the same key always produces the same hash, and the same hash always compresses to the same slot, storing apple and later looking up apple will always point to the identical location. Consistency is what makes O1 retrieval possible. A well-designed hash function is built so that even tiny changes to the input produce wildly different outputs. This is what spreads keys evenly across all your slots instead of clustering them together. Even keys like cat and cats, just one letter apart, should land in completely unrelated slots. Here's the honest limitation. No hash function is perfect for every possible input. Collisions can still happen, just rarely if the function is well designed. That's exactly why hash table performance is described as O1 average case, not O1 guaranteed. There's always a small chance of unlucky collisions clustering things up. Here's the mistake that trips people up: assuming hashing is random. It's not. Hashing is completely deterministic. The exact same input always produces the exact same output, every time, forever. What looks random is actually the hash function's design, spreading similar inputs apart on purpose. Confusing spread out with random is a subtle but important misunderstanding. A hash function converts your key into a number, compresses that number into a valid slot using something like modulo, and consistently lands the same key in the same slot every time. Good hash functions spread similar keys far apart, which is what keeps lookups close to O1 in practice, not in theory alone. This is video 13 of the full DevVerseX Data Structures and Algorithms course. Subscribe so this keeps stacking together properly. Coming up, Sets Explained, a structure that's secretly just a hash table wearing a disguise.